তো আমরা করব হচ্ছে বেসিক্যালি আজকে সাইক্লোঅ্যালকেনস, ঠিক আছে? সাইক্লোঅ্যালকেনস এবং তাদের সাথে সামথিং দ্যাট ইজ কল্ড অ্যাঙ্গেল স্ট্রেন, ঠিক আছে? অনেক সময় অ্যাঙ্গেল স্ট্রেনটাকে উই কল ইট অ্যাজ বেয়ার স্ট্রেন, ঠিক আছে? উইল নো হাউ। So our topic is cycloalkane and strain. So when scientists started analyzing cycloalkanes what? This is a cycloalkane. This is a cycloalkane. So when scientists started analyzing all these cycloalkanes, what they found is that number of naturally present cycloalkanes are generally 5-membered or 6-membered. Okay? So it was an observation that generally cycloalkanes occurring are either 5-membered or 6-membered. Okay, but number of cycloalkanes occurring as 3-membered or 4-membered are very less. Okay, so this was an observation. So why this was so? So from this we could have concluded that 5-membered or 6-membered ring is more stable than 3 or 4-membered ring. So that is why 5-membered or 6-membered rings are much in number than 3 or 4-membered rings. Now, next came what may be the possible criteria to understand this, that why 5-membered or 6-membered ring is much more stable than 3 or 4-membered ring. So the first thing, Baer, a scientist, came out with a theory which we nowadays call as Baer strain theory. We never call this as Baer strain theory, we call it that as Baer strain theory. So this strain is associated with Baer. It is not strain theory, it is Baer strain theory. Clear? So that means sometimes it can also be called as angle strain theory. Actually Baer brought about something called angle strain. Baer brought about something called angle strain which you will study. It is not strain theory, it is angle strain theory. Sometimes this angle word is replaced by Baer. So angle strain and Baer strain is synonymous. Okay. Now what does this really mean? So let us first write the theory, then after that we are going to understand. So Baer gave a proposal in 1885. What was Baer proposal? Instability of, so we will write Baer proposal. What was Baer proposal? Instability of 3 or 4-membered ring is due to angle strain. So if there is a strain, there will be lessening of stability. Okay. So we have proposed that the 3 or 4 membered ring are having more instability than 5 or 6 membered ring. Okay. Now why and how we will go. So what is stability then? What is stability? Now next we are came with another postulate, stability of planar. This is very important word, planar cycloalkane. Very important word, planar. Planar cycloalkane is directly proportional. Is directly proportional to how close is its bond angle. How close is its bond angle to 109.5 degree. Where came out this one. So that also we need to understand that how where said this one. So let us first understand this part, these 2 points, then we will come to other points. So these 2 points, how close it is its bond angle to 109.5 degree, how does this really affect the stability? Let us understand. So in a cycloalkane there are 3 carbons like this, bonded by sigma bonds, Now in normal alkane this is like this, right? Not like this. Both are sigma bonds. Clear? Whether it is propane or cyclopropane, everything is sigma bond. Now let us understand how the sigma bonds are going to overlap with each other. The overlap of the sigma bond. So that we need to understand. Here the carbon is having 2 bonds with other carbon and 2 other bonds are with hydrogen. Correct?
Yes.
What is the hybridization of this carbon atom? sp3. Perfect. So this is a sp3 hybridized carbon atom. Any carbon atom having all single bonds are sp3 hybridized carbon atom. Similarly, this is also sp3 hybridized carbon atom. Correct? Clear? Here the bond angle for any sp3 hybridized carbon atom is how much? 109.5 degree for any sp3 hybridized carbon atom. So in case of propane also it is 109.5 degree. So all these bond angles are 109.5. Though it doesn't look like because I have drawn a horizontal line, that is why. So suppose I take this carbon. In case of propane, hydrogen will be on this side, another hydrogen will be on this side, one CH3 on this side, another CH3 on this side. So it will have 109 degree with each other. 109.5 degree. These are at different planes. These are not in same planes. So if you take this as the same plane, it may not look as 109.5 degree. But if you take this as a different plane, suppose this CH3 is like this, and this hydrogen is like this. So 109.5 degree. But if I look from that side, it may look 20 degree. The difference between these 2 hands. Okay. So as this CH3 is protruded outside, and suppose this CH3 is protruded inside, the actual angle between these 2 CH3 is 109.5 degree. So this is how 109.5 degree angle is possible in sp3 hybridized carbon atom or any other sp3 hybridized atom. Now over here also the carbon is sp3 hybridized. Now when I am talking about a planar cyclopropane, so planar means the cyclopropane carbon should lie on a plane of paper, along with the hydrogen atoms will also lie on the plane of paper. So it should be just like this. There is no carbon atom inside the plane of the board, no carbon atom coming out of the plane of the board. It is always planar. Cyclopropane, I am talking about cyclopropane is always planar. Why? Suppose I have taken 3 carbons, 1 carbon here, okay, another carbon here, another carbon there. So you will say that this is not planar. No, it is also planar. I can prove. How? Here is 1 carbon, here is another carbon. Okay? Now the plane is this side, not this one. The plane is this one. Okay. Normally we take plane as this. This is the plane. Okay. So if 1 carbon is over here, 1 carbon is over here, 1 carbon is over here, we take top. This is a planar in the same plane. But if 1 carbon is here, another carbon is here, another carbon is on this side, then I will just change this. This is separate plane. Or like this. But still it is a planar. So cyclopropane can never be non-planar. You can write this down. Cyclopropane can never be non-planar. It is always planar. Done? Next. So this is a planar molecule. Now this is a triangle, an equilateral triangle. What is the bond angle over here? Has to be 60 degree. Can you make 109.5 degree over here? If you make 109.5 degree over here, then you can't form a triangle. Because suppose I want to make like this bond, I have to make it 109 degree. How will you form a triangle? Now next one you want to make this 109 degree. Never. It will never come because these 2 points are not going to join. So if you have to join these 2 points, then it has to be 60 degree. So cyclopropane has a bond angle of 60 degree. Now my question is, an sp3 hybridized carbon atom has a normal bond angle of 109.5 degree. But in cyclopropane, that sp3 hybridized carbon atom is being forced to form 60 degree. So there is something extra happening over here. Some force is occurring. So this is against the will of this carbon atom. This sp3 hybridized carbon atom want to remain as 109.5 degree, but to form this cyclopropane, you are making it 60 degree. Clear? So can we say that this is the normal? We know very well why these angles are done, why these angles are fixed 109.5 degree, because at this angle the repulsion is minimum and stability is maximum. This is as per VSEPR theory of chemical bonding. Okay. But at this moment we are seeing it is going to 60 degree. Okay. So that is why a force. So you have to agree at this moment these bonds are under some strain, because I am pushing or rather compressing from 109.5 degree to 60 degree. So there is some strain. This strain is called bare strain or angle strain, because due to this strain, or you can say due to the cause of this strain is due to the push from 109 degree, 109.5 degree to 60 degree. Clear? So I can say from 109.5 degree to 60 degree compression has brought about instability in the system. If there was no compression, no instability, compound would have been stable. So here I have written, or rather Baer had proposed, stability of planar cycloalkane is directly proportional to how close is its bond angle to 109.5 degree. So if it was, suppose the actual angle is not 60 degree, let's take the actual angle is for any other compound 108 degree. So then the bonds would have to be compressed from 109.5 degree to 108 degree, but the compression is much less. So instability will be less. So compound will be relatively stable. So that's what we have written. Stability of planar cycloalkane is directly proportional to how close is its bond angle to 109.5 degree. So as close it is, more stability. So cyclopropane is very far, because cyclopropane has an angle of 60 degree, very far, so it is very unstable compound. Okay? Next. You can write down. You can write. I have already said this. Write down. So to attain the structure of cyclopropane. So to attain the structure of cyclopropane, as shown above, we have drawn this diagram, right? As shown above, the sp3 hybridized bonds, or don't write bonds, sp3 hybridized orbitals are compressed from 109.5 degree to 60 degree. Are compressed from 109.5 degree to 60 degree. This is the cause of angle strain. Or what is the another name? Bear strain. This is the cause of angle strain or bear strain. Normally we know sigma bonds are very stable. It is a strong bond. Now in case of normal alkane, what happens? Suppose this is a normal alkane, ethane. The carbon is sp3 hybridized. So sp3 hybridized orbital does a head-on-head overlap to form this bond. This is head-to-head overlap. Direct collision. Okay, so this is a very good overlap. And good overlap will result in a strong bond. Good overlap will result in a strong bond. Normally this cycloalkane is like this, thick. Now these sp3 hybridized orbitals are at an angle of 109.5 degree. So definitely there is no problem in bringing these two sp3 hybridized orbitals in case of this ethane to have a head-on-head overlap. Suppose I have this orbital like this, normally sp3 hybridized orbital, definitely this orbital will not be at an angle of 60 degree with this one. This was at an angle of 109.5 degree. So this was at an angle of 109. Suppose I am taking this as 109.5 degree. The other sp3 hybridized orbital of this. Okay? But to form the bond with this sp3 hybridized orbital, suppose it is over here, then I have to bring this over. So I have to bring this. So when I am bringing this over here, then the total bond will be like this. But it is just to make it overlap. So what happens when sometimes we cannot catch some things directly? We try to আমের ডালের কথা ভেবে না, ব্রাঞ্চ অফ এ ম্যাঙ্গো। তুমি গাছে উঠতে পারো কিন্তু আমটা তোমার চাই। So what will you do? You will try to use some stick, bring that branch downwards and then catch that branch. That branch becomes unstable, weak, strain on the branch. Similarly, this is going to come like this. And is it not that here the bond will be like this? Just holding it to form a overlap. So here the overlap is good or bad? So this is a bad overlap. Due to what? Angle stress. Bad overlap. So as this is a bad overlap, so the bond will be weak bond. Bond will be weak bond. Bad overlap, weak bond. Hello? Now you have to understand another very important thing. In case of cyclo compounds, we have understood the conformational isomerism, eclipse conformation, staggered conformation. So in case of cycloalkanes, the hydrogen atoms eclipses one another. If you see this conformation, these are eclipsing one another. So you can write eclipsing of Ch bonds. So when there is eclipsed conformation, the distance between these two bond pairs of carbon and hydrogen atom is less. If it was staggered, it was more. Stability is less. If the bond pair distance is less, then repulsion will be high, stability will be less. Clear? বুঝতে পেরেছি এটা? হ্যাঁ? দুটো টাইপের কনফর্মেশন হয়। একটা হয় এরকম, this one, so this was staggered conformation. Here the distance between two bond pairs is much more because it is not a straight line. But here in case of eclipse, the distance is less. When the distance between electron pairs are less, the repulsion will be more, stability will be less. Repulsion more माने stability less. Simple. ठीक है? So eclipsing of CH bonds, this cause what kind of strain? This cause what kind of strain? What is the name of that strain? No. Bear strain is angle strain. That is done. Over. Now eclipsing of CH bonds, that is due to repulsion. See, this was due to pulling of one bond from 109.5 degree to 60 degree, or rather 90 degree, whatever angle you want. But this is direct repulsion between electron pairs. This is something else. So what kind of strain is this? Which we use in conformational isomerism. Torsional strain. So this is torsional strain. So both this strain act upon these compounds. So cyclopropane has high angle strain, that is Bear strain, and it also has high torsional strain. That's it. So cyclopropane, the angle strain is due to 109.5 degree to 60 degree. Now if we take cyclobutane, okay? So what happens? What is the normal angle of cyclobutane? We are talking about planar cyclobutane. 90 degree. It's a square. তাই তো cyclobutane মানে চারটে কর্নার, it's a square 90 degree. So the angle strain will be from 109.5 degree due to sp3 hybridization to 90 degree. So which will be more stable, cyclobutane or cyclopropane? Cyclobutane. Why? Because here the difference in angle is less, the pulling will be less, the branch will be much more stable. We are talking about only planar compounds. So cyclopropane we have seen only planar is possible. What about cyclobutane?
Difference less, pulling less, so
और pulling का लिखो ना आप लोग. सामने बुझाने के. Because the right like this. The difference between sp3 hybridized angle and the bond angle in planar cyclobutane is less. So angle strain will be lesser, so stability will be more. Well, next. Now, difference between sp3 hybridized carbon bond angle and planar cyclobutane bond angle is less. Hence, the angle strain will be less, stability will be more. Here, we are talking about only planar ones. Next, coming to cyclopentane. So, cyclopentane means what is the angle? 109.5 degree is constant. What is the angle of a cyclopentane? Planar cyclopentane, pentagon, polygon. 108 degree. I am not going to teach you mathematics that to of class 9th or 8th level. You have to find out the angles for yours. How to calculate angles in a polygon, regular polygon. बाड़ी जाओ, बाड़ी के देखो, खोजो खोजो बार बार, बोले दिया तो कुछ जगह नहीं. यहाँ बड़ा तुम, हो, की बोले? हाँ? 365 को 108 तो आसान है. 365 को तो अपना आसान है. तब वो तो भूल जाओ. हाँ? 365 করছো তো ওটা 180 থেকে মাইনাস করে দাও চলে আসবে
partial values by
হ্যাঁ হ্যাঁ এটা তো ওইভাবে কত 2n + 4 দিয়ে করে বলতে হবে তাই তো হ্যাঁ দরকার নেই ওটা 360/5 করলো 180 দিয়ে মাইনাস করে দাও হয়ে যাবে আরাম একটা ফর্মুলা দিয়ে ঠিক আছে ওকে ठीक है so this is stable or this is unstable cyclopentane very stable right let us go for cyclohexane hundred and 9.5 degree to cyclohexane angle 120 degree so this will be more stable than cyclopentane or cyclopentane is more stable So as per Bayer strain theory, cyclopentane is the most stable cycloalkane. But remember this word, this is only applicable for planar ones. Only applicable for planar cycloalkanes. Other than that, it is not applicable. Only applicable for planar cycloalkanes. Clear, Swali? Okay. Muslim? Next point. However, it was found out, in reality, it was found out that cyclohexane most stable, not cyclopentane. Why? Because during all this time while we are discussing, we are talking about planar cycle. So we could have easily calculated by regular polynomial formula that what is the angle between the sides. But in case of non-planar, things are not so easy. Okay? So see, in case of cyclopropane, we have seen that planar is the only option. But what happens in case of cyclobutane? This is a cyclobutane. Right? Cyclobutane. But I can easily take one of the points like this. Right? It is not planar anymore. And you cannot make this a plane. You can take 3 points and make that a plane. But you cannot take 4 points at any place and you can make it a plane. You cannot do that. You can take 3 points, any 3 points. Even if it is like this, you can take the other 3 points, make a plane. But the other point is not a part of the plane. Think? So cyclobutane need not be planar. Cyclopentene need not be planar. Cyclohexane need not be planar. So after cyclopropane, Bayer's string theory does not work. However, it was found out that cyclohexane is the most stable. More stable than cyclohexane is more stable than cyclopentane. Cyclohexane is more stable than cyclopentane. Think? Bullet point under that. Except cyclopropane, other cycloalkanes, except cyclopropane, other cycloalkanes need not be planar. Need not be planar. Next bullet point. They may bend, twist. Next bullet point. They may bend, twist, flex to change their structure in such a way so they have least amount of strain. They may bend, twist, flex their structure in such a way so that they experience least amount of strain. Now strains are of 3 kinds. Number 1 strain is, we have already studied, angle strain. So we know what is angle strain? Think. Number 2 is torsional strain. That also we know. And number 3 is steric strain. So angle strain is very much clear to us. That is when we have to bring the angle from certain degree to certain degree by forcing the bonds and the orbitals. Tanatani hachra hachri to jhamela to ache. Torsional strain is basically repulsion between 2 bond pairs. Repulsion between 2 bond pairs. Okay? That is torsional strain. Steric strain. What is steric strain? Steric strain happens when 2 or more groups come together or come very much close to each other. Simple matter. Nobody wants to walk in a crowd. They face steric strain. Like you guys are preparing for a competitive examination. So there, why it is called competitive examination? Because there is competition. The name came from there only, na? Lakhs and lakhs of students, 10 lakhs, 20 lakhs students are appearing, only maybe 30,000, 40,000 are selected in government colleges. So there is steric strain. And due to the steric, and nobody likes this strain. Nobody likes this strain. So if I don't like this strain, and I am made up of molecules, then why do molecules will like this strain? They also don't like this strain. So a hydrogen atom is like, say, a human being will not be very comfortable when he or she is competing with lakhs of other human beings. Huh? So similarly, a hydrogen atom is not comfortable when many other hydrogen atoms are around. So that is called steady strain. So what do you write? This strain happens when atoms or groups come very close to each other. This strain happens when atoms or groups come very close to each other. হয়ে গেল? বুঝে দিন? বুঝে দেবো?
The relation between the
Repulsion between two bond pairs. Okay. So we can write the next line. We can also write. So hereby we can conclude that Bayer's strain theory. Hereby we can conclude that Bayer's strain theory is not applicable for non-planar cycloalkanes. Is not applicable for non-planar cycloalkanes. Clear? Because it considers only angle strain. Right, Kiran? It considers only angle strain. Bayer strain does not consider torsional strain, steric strain and stuff. Okay. Next, planar cyclopropane. So, see, in case of planar cyclopropane, let us consider planar cyclopropane and planar cyclobutane. Now, if I ask you in which case the angle strain is more, in which case the angle strain is more, cyclopropane or cyclobutane? Cyclopropane. So cyclopropane has more angle strain than cyclobutane. Clear? Now what happens about the torsional strain? Torsional strain. So again I write planar cyclopropane, planar cyclobutane. What happens in case of torsional strain? Now I have to understand what is torsional strain and how can I answer this kind of question. See, in case of cyclopropane, what is the origin of torsional strain? Eclipsing of hydrogen atoms. So how many hydrogen atoms are there in case of cyclopropane? 6 hydrogen. In case of cyclobutane, 8 hydrogen atoms. So previously there was torsional strain due to repulsion of these carbon hydrogen bonds, which were 6 in case of cyclopropane. Here it is 8. So torsional strain is more in case of cyclobutane, because there are 8 carbon hydrogen bonds repelling each other. So it is more in case of cyclobutane. Clear hoche? So definitely cyclobutane will not want to experience so much amount of torsional strain. So cyclobutane, to reduce T strain, that is torsional strain, you will write complete what? By cyclobutane, to reduce torsional strain, what they do? একটা atom it reduces the torsional. Whenever it is moving that carbon atom in the other plane, the hydrogen atom attached with the carbon atoms are moving away from this hydrogen atom, and the repulsion decreases. Stability increases. So to reduce torsional strain, it becomes non-pure. If I want to show this cyclobutane, I can show it like this. So one of the point has come out, cyclobutane structure. Next we will do cyclopentane. Cyclobutane clear? Now what happens with cyclopentane? Cyclopentane has 5 carbons. So normally it has an angle of 108 degree, which is your bond angle if it is planar. So if it was a planar cyclopentane, then it is very stable. But planar cyclopentane has how many hydrogen atoms? 10. So the torsional strain increases. Okay? So we can write planar cyclopentane ten hydrogen atoms eclipsing one another. Eclipsed. So T strain increases. So to reduce this T strain, it becomes non-planar. How does this structure look like? This structure is often called as open envelope structure. So normally cyclopentane is like this. Normal cyclopentane is like this, isn't it? More or less. So what will happen? See, envelope. Open envelope. So এটা উঠে গেছে, বুঝতে পারছো? এটা উঠে গেছে, এটা লেগে নেই। অতটা আমি 3D তে ভালো করে আঁকতে পারছি না। So this has come out of the plane. So other 4 points are in the plane and the other part of the envelope is flying in the air. Clear? Open envelope structure. This is stable and this is non-plane.
So এমন হবে। এমন হবে।
হ্যাঁ, এরকম রয়েছে। মানে suppose this is the envelope. This is the envelope. Carbon 1, carbon 2, carbon 3, carbon 4. This is the carbon 5. So this one is like this. ঠিক আছে? তো হয়ে গেল না নন প্লেনার দেখো। এইটা একটা প্লেন, এটা প্লেনের বাইরে চলে গেছে। So this is non planar structure. This is stable. ঠিক আছে? So this is normal bare strain theory. So you have to remember one thing, that cyclohexane is the very stable structure. Okay, later on we will go when we again go into this conformational analysis. We will also do the various non-planar structure of cyclohexane. That is very difficult, but yes, that is difficult. লোকে বলে দেয় যে ইজি কোনো ব্যাপার না, ইজি করে করা যায় সেটা আলাদা বিষয়, কিন্তু মাথায় রাখা ডিফিকাল্ট। ঠিক আছে? তো দ্যাট ইজ দিস ইজ দ্য প্রিকারসর অফ দ্যাট। Okay, after that you will understand various non-planar structure of cyclohexane. ठीक है? Boat, chair,